Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true. Every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.fm radio. It is another Friday evening, and what do we do on Friday evenings, Nick?
We take over the world!
Thank you, Pinky. That's right. That was Nick Yvetz. My name is Marty Coons. It is Friday, May the 3rd, 9 o'clock in the evening for those of us here in the eastern portion of North America. Universal Time would put it at 1 o'clock in the morning. Saturday morning, the May the 4th be with you.
Yes, actually, that gives me the segue into posting my link for one of my first links.
Well, there you go. Before I forget, let's start it out now. We'll do it in the break too. We got a Comet Watch coming, a brand new Comet. Is it brand new Comet Watch?
Brand new Comet Watch.
Brand new Comet Watch.
We had the head of UK Mon, which is the organisation that monitors fireballs and meteors and all the good stuff.
Yeah, we got some meteor shower storms to talk about too. We'll get to those later. But all right, so Comet Watch coming up after the Event Horizon program. All right.
I don't know if everybody heard that from Starstorm. That was a shameless little plug.
Okay.
Oh, you're right. It is a shameless little plug.
Well, they're shameless and shameful and whatever. So it's a plug.
So who have we got in the chat room, Marty?
Chat room? Oh, am I supposed to go in the chat room? I'm in the chat room. What's in the chat room? We got Groot, me, we got Black Projects, Glenn, we got Starstorm. Why aren't you in the chat room, Nick?
I'm in the chat room.
I don't see you in the chat room. I don't see you at all in the chat room. Unless you have are you Groot? Okay. That explains a lot.
Groot.
Can you hear background music? I've got a huge party going outside my apartment door right now.
I can't hear background music. But you're going to if there's background music, so let it be. Let the dance go on.
All right, so we're good that way. Hi, Nick, Black Projects, Glenn, Starstorm. Everybody can come on over to the chat room if you like. Go to the homepage, astronomy.fm. Yep, still temporary page. We're still working on it. And then you'll see the link for the chat room down at the bottom. Type in a name you want us to be referred to as, and then just hit login. If there's anything in the password, just erase that. Leave it password blank. Hit login. You'll be here in our chat room where we have conversations going on, sometimes of astronomy, sometimes other subjects. We have some pictures. People are posting their astronomy pictures in there, stuff like that too. So, yeah, come on over and join us. It makes it a little bit more interesting. Ask us questions if you'd like to about what the heck we're talking about sometimes. I don't even know. I'll ask that question sometime. I'll type it in chat. What are we talking about?
At the moment, I think the first comment you made was about May the 4th. But yes, tomorrow it's Star Wars Day. And as I say, we're all thinking about the late, great Peter Mayhew. We have lost Chewbacca. 74 years old. He was, even at 70-odd years old, he was working on The Last Jedi.
Well,
now, there is commitment to your character.
I have lost track of all of the Star Wars movies, actually, because they were like, I understand the 9 in a row, but then they kept throwing in these other side stories and spins and stuff like that. So I've lost track of all those.
Okay, so you've got the stories about Rey and Han and Leia Solo's son.
Okay.
Then you've got The Last Jedi. There was Solo, which was the Han Solo story. It was a spin-off.
Okay.
It was a good one. I have been watching the trailers for The Rise of Skywalker. This is supposed to be the last one before it goes in a completely different direction.
Okay.
And I like it. Lando Calrissian is back.
Ah, okay.
And it's the same actor, actually, from what I can see.
Oh, wow. Nice. Forgot who that was.
Billy D. Williams, I believe.
So that sounds right. Something like that.
And in fact, his son played the young Lando in the spin-off Solo.
Oh, nice.
Yeah, I thought so too. It's nice to have a bit of continuity
in the family. Yeah. All right, let's do some astronomy stuff. By the way, that remember that big sunspot that was around a few weeks ago? Went across the sun, that big one. It should be about ready to come back anytime now. In fact, they're detecting a lot of solar activity just around the solar limb on the side that's going to start rotating towards us. So get ready next couple days, or in fact, if you have like a hydrogen alpha telescope, start getting it out and looking at that eastern limb and see if you see some flaring from beyond the horizon, and then some good prominences and stuff like that. And then there should be that spot rotating on. So it should be good for, say, first will be hydrogen alpha viewers, and then after that, even white light scopes will be able to see that big spot come around. What they're thinking it is, it should be the right spot, and it's got a lot of activity. So it should be coming around and giving us a nice view. So maybe we even get some blast from it and get some good aurora or something like that. So
that would be nice. Mind you, having said that, when I go outside, when I stick my head out of the window, it's wet.
I've got the same thing, cloud cover. Not seeing nothing tonight. So, all right, so keep an eye on the sun that way. What else have we got coming around? We got launch tomorrow morning, actually. Does it say when? What's at 2:48 Eastern time? And it's 9 o'clock now. So about 3 hours, a little less than 4 hours from our first broadcast time right now. So that is going to be a SpaceX cargo launch to the International Space Station, and that you can actually tune into NASA TV at 2:30 a.m. Again, launches at 2:48 scheduled. Speaking of SpaceX, and they have released some information. Well, somebody did information. Where is that article on? There it is. The SpaceX capsule incident. They're now saying it was destroyed.
Well, you know what, Marty?
There's a ground test, by the way. Ground test. Go ahead.
There's a ground test. They were testing the abort engines.
Yes.
And to be honest, you are going to lose equipment in ground tests.
Mm-hmm.
The whole point of the ground test is to make sure that a piece of equipment that may never be used will work.
Yep.
And it's a case of, well, you live and learn, because obviously some part of the test went wrong and the capsule was destroyed.
Mm-hmm.
But this is the important thing. At the end of the day, it's a learning experience. And that when it happens, you can say, well, this is what happened, and then this happened, and then this happened, because everything is filmed from every conceivable angle, in regular speed, in slow motion, so that the engineers can actually go over the whole thing with a fine-tooth comb. We did it with Apollo.
Mostly with testing monitors, not just video, but things that'll be monitoring all the systems and see if there's anything unusual. And then, of course, later they'll just basically test all the parts, the metal quality, and things like that, and be able to hopefully figure out what went wrong, fix it, and test, and then if it's ever needed, it should be good to save them during an aborted launch.
Space is a dangerous place.
Mm-hmm.
We got I don't know if I've said this. I've said it before. I'll say it again. We got extremely, stupidly complacent with the shuttle, and the result was we lost
times. Yeah. Drag racing's a dangerous activity too.
Well, crossing the road's considered dangerous, but
airplane racing is a dangerous activity. Skydiving is a dangerous activity. So yeah, they'll fix it. Figure out what's wrong. And like you said, might even never even need it. But if they do, at least they'll know it's good. In fact, actually, they could launch with it Well, you got a couple choices too. You can actually launch without those booster rockets and hope the launch goes good, or you can launch a lot of times without ever having to need those escape rockets. And in the meantime, they can keep testing those escape rockets on the ground, stuff like that. So, a lot of options. Obviously, going to slow them down a little bit, but they'll get there. So, I guess they don't have, escape rockets on the cargo missions going to the space station, I guess.
They don't need
I would assume, yeah, it's just cargo. So if you're launch ports.
But as I say, the thing is, it's launched successfully, it's re-entered and splashed down successfully, which is the most important thing. And at the end of the day, testing backup systems means that you're doing everything possible to make sure that it's as safe as can be. I'm sorry, space will never be totally safe. It is one of those.
Calculated risk.
It's a calculated system. Calculated risk.
Space is not safe for the Earth.
No, it's not. We've got so much junk up there that it's beyond a joke.
No, I'm talking about like asteroids and stuff, like cosmic rays, asteroids, near too close supernovas, anything can get us.
You get exposed to cosmic rays, Marty, when you fly on an aircraft.
Yep.
In fact, nowadays, what they do, they analyze the routes. Aircraft carry dosimeters, and they analyze the route on a regular basis to try and see what the risk is to the passengers. That's right, Glenn. Life isn't always safe.
It's a crew mostly.
The crew get the higher dose than the passengers. It really depends on how much flying you're doing as a passenger.
Well, yeah, as a crew, they're obviously flying a lot more than passengers are, so they'll get dosed a lot more, so they'll have monitors for stuff like that, too. So, hey, like you said, they change the route, so during times like this when there's high cosmic rays, I don't know. When the sun's really active, then the North Pole route is really dangerous, but when the sun's not active, then all of it's dangerous.
Well, just to reply to Glenn, there can only be one, Glenn. There can only be one. Look after your head, Highlander. Glenn made a comment. Do you figure on being immortal? No, I don't want to be immortal because after a couple of 100 years, it's going to get extremely boring. Unless, of course, we have space flight into the solar system, which might make it worthwhile.
I'll take immortality for at least a little while, a long while. Yeah,
but we'll see. We'll see what happens. If you're an immortal, you'll be the guy they send on the long distance space mission out of the solar system.
Yeah, especially if you make somebody mad. Yeah.
But seriously, just living every day is a risk. It's a calculated risk. You decide what risk you're going to take and what you're not going to take. And if you decide to take the wrong risk, it's hasta la vista, baby.
Speaking of problems in space travel, NASA just released information about a couple of launch failures from Launch Services Program. No, the investigators have determined. Well, they got some. It was the Taurus XL rockets. They had some failures. It turns out some of the aluminum that they got was not up to standards. So they had some support pieces that broke at launch, and the rockets crashed. And it took them 10, 20 years to be able to totally figure it out, but they did figure it out what went wrong, and it was the supplier. That they didn't, if they had test information, they didn't release the test information, or they covered up the test information that would told them that it was like not proper metal that they were putting in their support brackets, and so it's all figured out now. That's what was wrong, and NASA won't buy parts from them ever again, or maybe other people too.
Yeah, well, once you get blackballed by somebody like NASA, then everybody says, "Oh, I don't think we're going to go there for brackets anymore."
Yep.
Anyway,
Put this article in our chat room here.
Yeah, I've put an article in. Yeah, probably was the lowest bidder too. It does happen. Anyway, Eta Aquariids. The radiant is shown on the link from latitude 30 north, Houston, Cairo, Delhi, and Shanghai. 90 minutes before sunrise on Sunday. Further north, the radiant is lower in the sky when it starts to get light. Shower members can appear from anywhere across the sky, but they all trace their paths backwards into the radiant. And that is the constellation of Aquarius, the water jug, the water bearer.
Mm-hmm.
So, what else do we know?
A little straighter, because
What was that, Starstorm?
you mentioned Aquarius.
Yeah, it's the dawning of the age of Aquarius.
There you go.
Anyway,
the name they call is Aquariids, which is kind of hard to read when you look at it.
Yeah. Anyway, so if you haven't paid much attention to the shower due to its early hour, it's perhaps time to commit to it. These speedy little objects from the constellation Aquarius may be the last good meteor shower for about the rest of the year, they reckon. Blame the moon. The richest showers, the Perseids and the Geminids, will take a severe hit from moonlight this year. In both cases, the moon will be at or near full and up most of the night. Even October's Orionids will only limp along thanks to our last quarter moon. Now, as I say, most people don't. This has been a shower that's not really been much of a goer, but its parent
it can be.
But it hasn't always been a brilliant shower. In fact,
Right.
at one point, everybody thought it had disappeared. But they reckon it's going to be back this year and one of the best meteor showers of the year. So if you can, do get out and have a look for it.
Yeah, in fact, you can even start early. You know, it's not going to be for another day and a half or so, but start now, because obviously they're a little bit spread out. So anywhere between now and the 11th of May, you can be able to see some of these. Now, these are best for low northern latitudes and southern latitudes. So anything above 60 degrees north, you're not going to see any of them. But they pretty much go down to pretty far south, I think, if not even. Yeah. Only zeros out at Antarctica.
So for tropical,
go ahead.
I was going to say for tropical and southern latitudes, the shower is a solid hitter with a peak of about 40 meters an hour.
Mm-hmm.
For mid-northern latitudes, that number will be closer to 10 or 20, because the radiant only climbs about 15 to 25 degrees before the start of morning twilight.
Mm-hmm.
The maximum starts Sunday morning, the 5th, in the small wee hours before dawn. So you're going to need to be getting up at about 2:30, 2:45, and be outside by 3 o'clock, 3 to 4:30 a.m. to make sure you don't miss that window.
Mm-hmm.
So there's more information in the article. Well, apart from the fact I've got solid cloud at the minute, and I'm not supposed to get anything else, but this is about typical.
I had to check my weather too and see what it's going to look like. There's another couple of days. If any of this is going to break, that would be nice. But got another one coming up after that. A couple more days.
Yeah.
The Eta Lyrids. They're active from the 6th to the 13th. They don't have an exact most activity around the 11th. Okay. So that one's coming up. So if you missed this one, then maybe you'll catch the Eta Lyrids coming up a week later.
And of course, this is one of the meteor showers that's actually associated with Halley's Comet.
Mm-hmm. Yes, the Aquariids.
Yeah, and this was enriched.
Yep.
Yeah, this was enriched back in 1986. And like I say, it's going to be kind of nice because it's new moon and everything. And
it's new moon?
Yeah, it's new moon. New moon on Sunday. I'm showing my age here, aren't I?
So, so if there's new moon, that means we're probably not going to be able to see any moon strikes.
Well, actually, yes, because
should be so. Yes,
because the best time to look for lunar impactors from meteors is you have to look on the darkened portion of the disk.
Yes.
So if it's new moon, you have the whole of the moon as a target that will should be able to show something. Perhaps.
Unfortunately, new moon in the daytime is not a good thing to look for a meteor strike. So yeah, too close to the sun. So you got to get a little ways away from the sun. But the meteors are coming from the opposite side of the sun. So it's like it's a big target for those meteors to hit. But unfortunately, it's towards the daytime side, so no good there. So if we wait till around like quarter, well then half the dark side is missing from your view, and they might get a good strike on the far side of the dark side and not getting on the near side of the dark side. So it's a little bit of everything, luck, and what you can see and not see.
Now the interesting thing is, of course, when we're seeing them at the moment, we're seeing the Earth plowing through the debris on the outbound leg of the comet's orbit every May, and we see this meteor shower again every October on the inbound leg. Because believe it or not, what is the other meteor shower that Halley's Comet is famous for enriching?
Is it Perseids? No, it's not Perseids. It's Lyrids, I think. Right?
It's one of them, and I forget. I haven't.
Oh, I thought this was a quiz. You're asking because you don't know.
Well, actually, I should know this because I've actually discussed this before on Comet Watch.
Okay. Okay. Yeah, you do Comet Watch, so you should know all these things. And well, if we're not sure, stay tuned to Comet Watch coming after the Event Horizon tonight. You'll find it. We'll leave it that way. We'll leave it as a mystery. We won't actually answer that question, so people will have to listen to the next program and find out for themselves. So, film at 11.
Yeah.
But this is radio, so maybe not.
But as I say, one good book I really do recommend is David Levy's Guide to Observing Meteor Showers, because he does go into which object feeds which meteor shower throughout the year. So
yeah, it's good to know.
I can hear your party now, definitely.
Good to know what's coming up, because sometimes you see some random ones and then you wonder if they're, coming from a shower that hardly has any. Well, if you already know what showers are active during the time you're out and you watch carefully, you can trace them back, and there's a chance it was from that constellation that's having that meteor shower. I mean, it might be one that's past it, might be one that's short of it, but if it's lined up, at least you got 50-50 chance or so that it was actually from that other meteor shower, lesser known meteor shower.
Well, actually, Glenn's asked a question: when will Venus be better to view? Well, Venus is actually both the morning star and the evening star, because the Greeks and Egyptians thought Venus was actually two separate objects.
So he wants to know when it's going to be. When can we see Venus next? Is that what he's asking?
Yep. What I'm seeing here, on the morning surrounding April the 16th, Venus will approach to within 5 degrees of Mercury. Venus rises roughly 80 minutes before the Sun. The planet is so bright, magnitude -4, it's still prominent low in the east-southeast, despite the growing morning twilight. That was back in April.
It's still a morning object.
Still a morning object, yes.
Yep. And let's see which way is it actually going. It is going. Where is it going? It's going towards the sun. All right, so that means it's going around the backside of the sun, and it's not going to get around there till like November or something like that. So it's going to be in the morning till about November-ish. So still some nice planets and the moon coming up. Let's see. Can we crank it one more day? Oh no, the moon's going too close to the sun. Mercury and Venus, and technically Uranus are still there early in the morning before the sunrise.
So I like Venus as a morning object.
I don't. I don't see it.
Yeah, I know. You live in Michigan, don't you, Marty?
Yeah. If you were
anyway,
out there this morning, though, that would have been a really nice view. A thin crescent moon, really close to Mercury, and Venus nearby. That'd be a
and
super. Saturn's there too. Oh yeah, day before was
1 hour before sunrise.
Yep. Day before was good too because the moon was by Venus then.
So
And
all week, Saturn will remain almost stationary with respect to the Sagittarius. I hate it when they call things like the Sagittarius teapot. So it's going to be stationary in regards to Sagittarius in the early dawn and before.
Okay.
So if you look at, I'm going to put let's put the sky, the night sky for a week in.
Jupiter and Saturn are really nice. Yeah, kind of early in the morning, 5 or so in the morning, in Sagittarius Scorpius region, right in the middle of towards the heart of the Milky Way, the core of the Milky Way region. And then,
in fact, it's new moon exactly at 6:46 p.m. Eastern Daylight Time on Saturday.
Okay. So I think Saturn and Jupiter would be the prominent ones in the morning, and then just before sunrise, if you have a really good eastern horizon, you'll be able to pick up Venus and the moon and Mercury. No, not the moon. That's too far, too close to the sun. Venus and Mercury, but those are going to be kind of tough ones to do.
Yes, Evil Spock, we are most definitely live tonight.
Mm-hmm.
We are. Right, is there a planet that can show phases? Yes, Venus. Very simple answer, that one. Also, okay, so Monday, Wednesday, May 8th, look for a very thin crescent moon 45 minutes after sunset. And if you look over towards Taurus, on the 7th, you will see Mars.
Yeah, Mars still hanging around. Surprising how long Mars stays in the sky, you know.
So basically, by Monday the 6th, there's a very thin crescent, a few degrees above Aldebaran. On the 7th, the crescent moon hangs in the west-northwest at dusk near Mars and Beta Tauri, which is to Mars's left, and very close or even on top of third magnitude Zeta Tauri. So, will the moon occult Zeta for your location? It will if you're in Florida or the deep south. So you've got something there, Glenn, where the moon will be low in darkness, the mid-south with the moon higher in twilight, or much of Mexico and Central America. So see the maps and timetables from IOTA. The text there consists of 3 timetables for the star disappearance there, its reappearance, and locations of cities and towns. Watch for divisions between the tables as you scroll. So let me just open that in a new tab, and I will put that in. Okay.
All right. Yeah, we're starting to lose those December constellations all around Orion and Taurus and Canis Major. Juno's still up there, by the way, between Betelgeuse and the foot of Gemini.
Betelgeuse.
Got the Betelgeuse. That's more accurate. Yes. Still got the asteroid Juno in the area.
Yeah.
But that's going fast. Yep.
Wednesday, May 8th, the crescent moon this evening shines in the feet of Gemini, far below Pollux and Castor. Whilst twilight is fading, look for Betelgeuse twinkling a similar distance below the moon. The brightest star high in the east these evenings is Arcturus. Spica shines lower right of it, about 3/5 at arm's length, and to the right or lower road to Spica by half the distance is the distinctive 4-star constellation of Corvus the Crow. Hi, Uptronics. Nice, glad you made it, mate. So, by Thursday the 9th, the thick crescent moon shines in the west after dusk, with Pollux and Castor to its upper right, and for Scion, further to its lower left. Okay, officially, summer is more than 5 weeks away, but the summer triangle is beginning to make its appearance in the east, one star after another. First is Vega, already low in the northeast as twilight fades. Next up is Deneb, lower left of Vega by 2 or 3/5 at arm's length. It comes above the horizon when twilight fades into full night, depending on your latitude. Third is Altair, which shows up far to their lower right around 11 o'clock or midnight. Now, Friday the 10th. This is a good time to be taking binoculars out and looking for the lunar X. The moon is nearly at first quarter. It crosses the Beehive star cluster M44 this evening for much of North America. Many faint occultations will be visible telescopically on the moon's dark limb, according to David Dunham. Occultations of 6th to 9th magnitude stars in rapid succession will occur as 39% of the sunlit moon passes over M44, visible in part for most of North America east of the Rockies, with northeastern areas favored. A moon view and information about computing local predictions, again, go to the newly updated IOTA occultation campaigns page. The universal time date is May 11th, and I'll just click that into a link. Just 1 second, and I will put that into the chat room. Here we go.
For the moon going over the Beehive, that's not binoculars, because there's so many faint stars, and the moon's so bright, you're going to get too wide of a view. So that would be one with telescope. It doesn't have to be a big telescope. Even like a 60 millimeter refractor, and zoom in on that darker edge of the moon. Then you'll be able to see all those faint stars disappear, because you kind of get rid of that bright edge of the moon too when you zoom in more. And you'll be able to see more of the faint stars disappearing behind the dark edge of the moon.
Now, Optronics is asking in the chat room, SpaceX people, capsule blew up this week.
Yeah,
that was last week, wasn't it?
It was last week. Yeah, I got a link. I've got a link in there. So if you go back and chat, there's a link for that of what. Well, not exactly what happened, but they say it blew up. So I'm assuming it was one of the engines that couldn't handle the stress, and it cut loose. And sometimes when they cut loose, they can go through a fuel tank too. So, or the fuel just keeps pumping, and once it's blown and sparked, blows a hole in the line, then the fuel keeps pumping through the line. It's just like flame everywhere except where you want it to be.
True.
Hard to say if it was actually blown up or not.
Like I say, I think the thing is, what people forget is space travel is dangerous. Yes, there is calculated risk and there's damn full risks. And the whole point of testing like this is to get rid of the damn full risks.
Yeah. Everything's dangerous. Driving a car with me is dangerous. I'm that kind of guy.
I wouldn't know, Marty. I've never driven a car with you in it.
That's true.
I might drive a tank with you in it, because that's probably the safest thing for me. But not for anybody else who happens to be in our way.
Depends on how big the cliff is. All right, let's do a little.
I'm getting slapped over here.
We got to do a station ID here, so we'll do it right now. You're listening to the Event Horizon here on Astronomy.fm. It is Friday evening. This one is May the 3rd, 2019, about 9:30 in the evening. Eastern Daylight Time for those of us here in the eastern portion of North America. Universal Time would put that up right around 1:30 in the morning, Saturday morning. May the 4th be with you, 2019. Still got some more programming coming up after this. Don't forget, we got it's usually a big Comet Watch coming up right after the Event Horizon. And don't forget, you still got another half-hour program, so live stuff. So come on over to the chat room. Go to astronomy.fm, and you'll see down at the bottom where you can get into the chat room. Just type in a name, hit login, and you'll be here. If you've got questions for us, feel free to ask them in the chat room. So I want to say hi to everybody in the chat room so far. We got you and me. We got Glenn, Starstorm, Evil Spock, and Optronics in our chat room right now. So come on over. Always a conversation going on.
Driving in the UK is dangerous. Everybody's on the wrong side of the road. Hey, guess what? Driving in the US is dangerous.
Well, yeah.
US drivers are the worst in the world.
Not necessarily. Every country's got the worst drivers in the world, so there you go. It's just a fact. Let's see. Bright Star occultation. We talked about some of the dim ones, but on May the 8th, we've got Delta Taurus being occulted by the moon. That'll be from southern U.S., Mexico, Central America, and the Caribbean. And also on May 8th, New Gemini. That's a 3.5 magnitude star, be visible from southwest Africa and Madagascar. The moon covering that. And we'll do one more the 9th. What's it? Beta, Gamma, Delta, Geminis, Central Africa visible, and Southwest Middle East.
Glenn, I've been to Ohio. I know how they drive there. New York State and Massachusetts drivers, to me, are the worst. Our director, Rob, is saying that he reckons Brighton, UK is one of the worst places to drive in the world.
It's everywhere. It's all relative. I mean, some people can't drive in mountains, and I've driven in mountains, no big deal, but some people can't do it at all. So it's all relative. And then you got, snow and ice-covered roads for some areas all the time. And if you're used to it, no big deal. If you're not used to it, it's, more dangerous than other areas. It's all relative. Then high mountain driving. I remember was it actually get picked for the jury? I can't remember or not, but one of the questions was about a dangerous road, and I thought, well, there's places where the roads are dangerous, and there's places where off the road is dangerous, and there's places where both of them, on the road and off the road, are dangerous. So it's just all kind of relative. So
okay, Optronics was asking about a link to the SpaceX Dragon capsule explosion.
I put that in there. The one I had.
Yeah.
Yep, should be there somewhere.
Yeah, there's one investigates good covers the cause of 2 science mission launch failures. But
I got an article on a space rocket that hit the moon at 61,000 kilometers an hour. I'll put that into our chat room.
Was that the Israeli lander?
No, it says rock. So it would not have been a lander. I'll put this in the chat room here. There you go. Just saw this one, so I didn't get a chance to actually read when it was. Oh, that's a pretty good blob. Article's published May the 1st, so just a couple days ago. Was this a total eclipse one? Oh, maybe this is a total eclipse one. Old news. Why did it just go in now? I don't know. Maybe because they found the crater that was part of 10 to 15 meters across. Maybe that was it. Okay. A little bit of old news, but a little bit of new news, too.
This is true.
Let's see what else we got going on. So, if you had a chance you're still working on a telescope for yourself, aren't you? Still working on that project?
Yeah.
Get some more equipment in yet?
The only recent equipment I've got is radio gear, because one of the things I'm doing to the warm room is I'm fully equipping it with HF and VHF and UHF, so that I can literally be imaging, and I can be yakking with astronomers on the other side of the world. Ionospheric conditions permitting, of course. But there's quite a few astronomers who are radio amateurs. So if I need to, I can always go into G, which means I'm working stations in the UK, and discuss imaging techniques and all kinds of fun things. It's interesting. The last time I actually was on a HF radio net, and we got discussing astronomy. Quite a couple of amateurs from Europe got very upset with us because they wanted to boast about their 10 kilowatt radio stations, and we weren't interested. We were too busy discussing CCD cameras. But there is actually a VHF radio net out near Chicago, where they just talk about astronomy, which is kind of fun, really. And you can, if you have a license, you can echo link into them if you're not in the US or close by, or you can listen to recordings of some of their nets. They're called SWOG, as I remember. I'm actually signed up. It hasn't been very active recently, but who knows? It just takes something. And of course, some of us are still talking about setting up our own nets to hand-on observations, particularly with comets. I know that was something Terry Lovejoy and I discussed many moons ago on Comet Watch.
Mm-hmm.
But it would be fun to coordinate an imaging run by amateur radio.
Mm-hmm. Got a little, let's see, another occultation. This one is, of course, by the moon, but it is Saturn coming up on May the 22nd, but mostly for Australia, and it's mostly going to be an daytime event. But still, it's pretty good. Or the very southern tip of Africa will be able to catch it too. Mostly Saturn occultations are, they're all the southern hemisphere, and the occultation zone is actually getting farther and farther and farther to the south. And then to the end of the year, it's going to be Antarctica will be the occultation zone to look at these things. You're going to say?
Well, as I say, the other thing is, radio amateurs I'd love to do is during a meteor shower, is to bounce VHF and UHF radio signals off them, and just to see how far we can get. Now you can actually do it with a traditional commercial FM receiver. What you need to do is to tune. You need to know the frequency of a radio station that you can normally get. And what will happen is when the meteor is going through the atmosphere and ionizing it and leaving an ionized trail, sometimes the signal will actually bounce off the trail, and you can pick up a station that may be 20, 30, 40 miles away that you normally can't get. So that's one way to do it. You can, where you can follow, I think there's two radars. The French operate one, and the US, I don't know if the US still does do it, but they actually bounce radar signals off them and track the meteor that way instead of doing it optically.
Now you'd have to tune into the station that's a ways away, like one station in Detroit, one station, or you're in Detroit, one station in Chicago. Tune into that radio station. Now you have to get the meteor between the two places, right? Between like Chicago and wherever I am in Detroit, the meteor would have to occur in between them in order to be able to pick up that signal, right?
Yep, because basically what it is, traditionally, if you're using high frequency or shortwave, the signal is able to bounce off the F1 and F2 layers, depending on the time of day. With VHF and UHF in particular are line of sight. We won't go into tropospheric ducting because that makes some people's heads hurt. And I know a few amateurs, when you start talking about it, like, oh, okay, thank you. We'll leave it at that. But what you can do is you can point a Yagi antenna at the area of the sky where where the trail should be. And then as you see the trail, you can transmit. Most of us now have gone over to doing digital transmissions for this. We're using a digital standard, so we're packing in our call signs, our locations, a greeting and a hello and goodbye, and a request to respond either through the internet with a report of where you are and what you got. So there's various exotic modes that the radio amateurs can use to do this. But as I say, it's good fun. But the really nice thing is it can be clouded out. You can be clouded out and you can still go meteor spotting. You can either do it the way with the FM receiver in your house, or you can do it with a transceiver, and you will hear it. And then you'll say, one meteor, click.
Mhm.
And some guys actually count the pings and pongs that they get from doing this, and the radar sets when they're active. I think spaceweather.com has a link to them occasionally. You will hear the pings when the transmissions bounce.
Okay.
So it's all good fun, and I must admit it is one heck of a way to spend an evening if you're cloudy, because then you can say, well, I counted X number of meteors from this storm or this radiant, and I said, but how could you? It's cloudy. I says, because I'm observing the radio wavelengths for them. A little bit of radio astronomy on the cheap.
There you go. Did you see this InSight lander picture of sunset on Mars?
The last thing I saw on Mars was about the Mars quake.
Okay, nope. InSight's got a picture of sunset on Mars. The sky is mostly blue, and the sun is just a pale orange color. So, no red sky in this one. Let's see if I can put that into our chat room here.
And of course, the really nice thing is you can go back to the show later on. It will be on YouTube, probably either late tonight or early tomorrow morning, and the links will be up there for you. And I really want to thank Starstorm for all her sterling efforts, because without her, it would be very, very difficult to do this. But it's good fun.
Yep. I want to remind everybody, since we're, like we talked about earlier, the new moon, this is galaxy season this time of the year in the sky with Leo and Virgo prime galaxy regions. So, and there's no moon to get in the way this next week or so. So if you like doing some deep sky observing of galaxies, this is a great time to do it, because Leo and Virgo are the places to go look for galaxies. And this week is the best. Another couple of weeks, the full moon's going to get in there and it's going to wipe it all out. So no good.
And of course, the real challenge is to try and image the Virgo supercluster.
Mm-hmm.
Yeah.
Yep.
Most people do Messier marathons on Caldwell or whatever, but a few people have tried to get all of the objects in the Virgo supercluster, and it is. I'll tell you what, it is difficult. Trust me.
Well, there's some faint galaxies there, so it's kind of like, what do you consider all of those galaxies? You can't necessarily get all the faintest ones too.
But it's interesting to see how many you can get. Obviously, quite a few people do it with the robotic scopes, which is just as valid. It's just as valid a form of imaging as freezing your backside off in your own garden with your own telescope. The only nice thing about it is you're warmer. You've got drinking chocolate, or coffee, or even tea, or maybe in my case a nice glass of wine. Just sit back in my chair and just wait for the image to form and go click. And then you've got to process it. Then you've got to pull off the flats, the subs, the lights, the darks, as well as your FITS files, and then you get to play with it. Happy days.
Indeed. Check out Hubble Space Telescope picture, part of the Hubble Legacy field. 16 years worth of Hubble images in this one part of the sky. So I won't mention more about it. Just go check it out. Check out the picture. Read the article. It's a recent release from NASA. Basically, it's kind of a history of the universe in one part of the sky.
See, the interesting thing, I don't know whether you probably agree with this, Marty, is with the Dragon capsule, with Orion when they finally get it flying, we can actually reconsider the idea of Deep Six in the Hubble. We could actually consider whether or not we want to refit it with the latest instruments and get some even more imaging, optical imaging out of it. Now, I do believe they have a couple of sensors for UV and infrared, not as good as the the successor to Hubble, which is the James Webb, which is behind schedule again.
No, I know. What can you do?
But I honestly think that the sweetest sweet in the sky will be the pairing of Hubble and James Webb. Imaging. One can image it in optical wavelengths, the other one can go into the near infrared. One of the things that NASA has done with its partners is with the X-ray satellites and everything else, is they have created some incredible combined wavelength pictures. They've even got data from radio telescopes in them. They've taken images, they've taken information from Chandra, from XXM Newton, everything, and they've blended it into one picture. I've seen some of those pictures, and the detail in multiple wavelengths is just incredible. You've got mapping that comes from the radio telescopes that shows the stuff that no satellite can see unless it's looking at radio wavelengths. It is an educational feast. That's all I will say.
Okay. Here's an article of dwarf galaxies and how they contribute to the Milky Way. They found this unusual star. It says it has an unusually low amount of magnesium. That's the 8th most abundant element in the universe, but it contains a lot of heavy elements like europium, gold, and uranium. Let me put that article into our chat room. So I think they're all basically related to what part of the Milky Way galaxy that the stars were formed in. So some heavy metal rich, and some of them missing a lot of basic elements to them. All right, let me get this into our chat room.
So isn't part of the equation the fact which generation star they are, because generation 2 stars lack a lot of what generation 3 stars have. Because what happens is when a star goes supernova, it seeds the space environment with elements like uranium, thorium, and all the other stuff, including hydrogen and helium and oxygen and everything else. So literally every time a star destroys itself like that, it's seeding the beginnings of new stars, really. So in a way, you progress from the generation 1 stars to generation 2 to generation 3, so that the interstellar medium is becoming so rich each succeeding generation that there is this wonderful potential for yet more star formation, and with more star formation you have the possibilities of new solar systems, and who knows where that could lead. We know that the universe is expanding, so this material, in some respects, this is my personal opinion, that this stuff that's coming into the medium is going to help fill the space as the galaxy expands. And of course, it means we can actually try and detect the invisible processes of the universe, so-called dark energy and dark matter. But that I think that does require more exotic detectors. One of which is the neutrino detectors, which is actually dry cleaning fluid in a huge tank underground. So that's how they detect neutrinos. When the neutrino goes through the dry cleaning fluid, it creates.
It goes in dirty and it comes out clean, and it's lot nice and shiny that way. They could see it better, right?
No, Marty. What it does is
it
causes a chemical reaction.
Okay, then that must not have been it then. That was just my guess.
That was your guess, this one. But as I say, it's incredible. Some of the things we're actually doing in order to detect these particles in real life.
Mhm.
Yes, the accelerators are brilliant. They can create little micro bubbles, in some cases, of the primeval universe. They can let us see exotic particles like some of the newer quarks that are coming out.
Mhm.
So, yeah, they're great. They allow us to see what does what with which, and how the particle decay affects them.
Mhm.
I think that I don't think really that the Large Hadron Collider is creating black holes, and even if it does, the size of the black hole is such that the event horizon, so I had to get the plug in,
There you go.
is so small it can't feed.
Yep.
That is why 42 is the meaning of life, the universe, and everything. 42 minutes is how long those little black holes can survive before they go poof in a Hawking radiation.
Speaking of what we call neutrinos, something that came around again, it was actually like from a couple years ago, but it seemed to make its way around, was about if you see this article on Facebook and stuff, scientists thought they discovered faster than light particles. Well, it turns out the particles were neutrinos. Now, what the experiment was is they would create particles with like the CERN particle collider. They would create the neutrinos, and they would have a detection station, I don't know, 100 miles away or 70 miles away or something like that. And they would calculate when the neutrinos were produced and how long it took the particles to get to the detection station. And the test thought that they got to the detection station faster than the speed of light. But it turns out there was just basically miscommunication between when they collided them and when they detected them. It was only like 70 nanoseconds, something like that. So it turns out that, nope. And with more and more tests along the same route, neutrinos do not travel faster than light.
Well, the only part... So, you want to finish, Marty?
That test has been confirmed over and over again. So yeah, it was like a problem with communication between the two stations. Go ahead.
The only particle thought that can actually travel faster than light is a tachyon. So, it is still technically a theoretical particle. We believe it exists, and we believe it can actually travel faster than light. The only problem is, if we were to generate a tachyon burst here and now, the chances are, because it can travel faster than light, it might actually do space-time as we know it a bit of a mischief, because basically Einstein has been proven time after time after time nothing can go faster than the speed of light. Well, if something can and does, could this signal, could this technically rip space-time? Again, it's one of those lovely theoretical things. No one can actually prove it yet. And until we can probably prove it, and it's probably going to be the time we say, oops, goodbye and thank you for all the fish. Because
so the question is, can a tachyon, being able to travel faster than the speed of light, be able to go back in time and kill its parents so it doesn't actually exist and not travel faster than light?
That would be an interesting concept. It's the old time travel paradox.
There you go.
We're not talking about paradoxes, please.
I've been told not to talk about paradoxes. Okay.
Okay.
Fudging does my head in.
It does. It starts still when I had this discussion, I think, after we went to see Endgame.
Zip it.
And it got quite convoluted.
All right, I got like one last article here before we run out of time. About a couple of neutron stars colliding. It says near the solar system, but sometime in the past, I guess it was. So, 4.6 billion years ago, but somewhere near the Earth. Well, maybe the pre-solar system or something like that. So, if you want. What is she saying?
She's saying slow down on the links.
Slow down on the link. The links will stay there for a little bit. Well, anyways, there's the article. You can read more on it. We are just about out of time.
Captain Savage, this is the away team. Myself, Marty, and Starstorm are ready to beam up. And I just want to say, we are Groot. There you go.
There
Anyway,
you go.
thank you for being here, and I hope you enjoyed the show. It will be YouTube fairly quickly.
Thanks, everybody in the chat room. Appreciate you all listening in. Good night, everybody.
Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.